Hi, so today we're going to look at a few topics. We're going to start with functions, domain, and range. So first to talk about what a function is, and you'll see this in your notes, but a function is any relation, meaning relationship between x and y or whatever the independent and dependent variable are. So it's a relation where each input has a single output. So each input can only be mapped to one output. So we're going to look at a few examples of domain and range. Just quickly, this will be kind of a quick little review of domain and range. So domain is the set of all of the x values in a relation, and the range is the set of all of the y values in a relation. So if we look at two relations here, this is just a relation. All it consists of is four coordinate pairs. So we are going to just list the domain and range, and the domain is the set of all the input, or x values, and the range is the set of all of the output, or y values. So in this case, the domain is just the 0, 3, 6, and 9, and that's it. The range is the set of the y values, so it's 2, 5, and that's it. You'll notice that we have 5, 5, and 5. There are 3 of the same y values. That's fine. We only need to write it once when we're listing the range. So this brings up the next thing. We want to tell whether the relation is a function. So each input is mapped to exactly one output, or has a single output value. So the 0 is mapped to a 2. You have the 3 is mapped to a 5, 6 is mapped to 5, and 9 is mapped to 5. Each input is mapped to a different output. So this makes it a function. You will notice that we have a repeating 5. The y values are mapped. The y value of 5 is mapped to more than one x value. That's fine. It can go that direction. We just don't want the input to have more than one output in order to be a function. All right, so let's look at this one. The domain for this one is 3, -1, 3, and -3. So again, I don't need to write this 3 again. I just need to write each one that occurs. And then the range here is the set of all the y values, 1, 0, 2, and 5. So when you have a relation expressed in this way, it's fairly straightforward to pick out the domain and range. It's just the set of the x values, set of the y values. This one is not a function, and the reason that it's not is that you'll see that this 3 input value has more than one output value, or y value. So the 3 is mapped to a 1, and the 3 is also mapped to a 2. So this is not a function. So if the x value is repeating, essentially, then it is not a function. All right, so let's look at this graphically and determine the domain and range, and again, whether it's a function. These are called discrete graphs. C and D are discrete. What that means is that there are individual points. They're not continuous. It's not a line or a series of connected points. They are discrete, just individual points, whereas E and F are continuous. And you can see that these are continuous in that every point between here and here is covered. Every point between here and here is covered. So they are continuous. All right, so let's go back to this example. We're going to determine the domain and the range. Well, I think the easiest way to do this is just to list what or write out what those ordered pairs are. And then it will look like this, and we can just do it the same way that we did for A and B. So in this case, that's -1, -1. We have 1, 1. We have 3, 2. And then we have 2, -1. So those are our points. And then if we want to write domain, again, it's just the set of all the x values. So -1, 1, 2, and 3. All right, and then the range is the y values, -1, 1, 2, and -1. Again, I don't need to write that -1 twice, so I'll just write -1, 1, and 2. And that is our range. Okay, so we want to determine if this is a function. If you look at it the same way that we did up here, as the set of ordered pairs, we can certainly do that. But there's also this nice little trick for graphing where you can just look and determine whether it's a function by something called the vertical line test. And the vertical line test just states that if you are able to draw any vertical line through that graph and it intersects more than once, then it's not a function. So if you can just think of like infinitely many vertical lines through this graph, if every single one of those vertical lines that you can imagine only crosses the graph one time, then we know that it is a function. If it crosses more than twice, it will not be. So if you can kind of imagine some vertical lines drawing through here. If we draw one through here, it only hits one of the points. If we draw one through here, one, and so forth. It only hits, if we were to draw a series of vertical lines, no single vertical line goes through more than once. So this is a function. So that is a function. All right, so let's look at this one. I'm going to skip the domain and range on this one because I think you can probably get the idea. We just write out those ordered pairs. What I want to focus on this one is that vertical line test. If you notice here, if I draw any number of vertical lines through here, what I'm looking for is, would any vertical line cross through the graph more than once? And right here, you can see that it crosses that graph more than once. So that tells us that this is not a function. So the vertical line test is really handy. You can just look at the graph and tell straight off the bat if it's a function or not. All right, so we'll also be able to do that with these problems down here. So the continuous ones, the domain and range is a little bit trickier for these because it's not just individual points, it's a whole range of points. And we have a couple of different ways that we can express this. In ALEKS, wants you to express it using interval notation. So just a note on that, if you see parentheses, this means open circle or not inclusive. Whereas if you see brackets, that means a closed circle and it is inclusive of that number. So we saw this a little bit when we talked about inequalities, like less than or greater than, and that is one way that you can express these, but we're going to use this interval notation. So on this one, think about domain. Domain is the set of all the x values. So think about your x-axis is here, and I should have didn't write that x and y there, but we have x and y axis. So if you think about your x values go from left to right on the coordinate plane. So if we go from left to right, the first one that you come across is at the point 0. So we're starting at 0. We don't see open or closed, but if you don't see an open and specifically open circle there, then we're going to assume that it includes that point. So we're going to use a bracket to show domain starts at 0, and then it goes to the point 1. So again, going from left to right, you start at 0, and then it goes to 1, and then it cuts off. There is no more of that graph to the right of 1. So we know that we're stopping at 1. It actually does include 1, even though that there's an open circle here. At this point, there is a closed circle, and that's the same x value. So it includes that 1 value, so we are going to use a bracket for that. All right, for the range you're looking at your y values, so you're going up and down your vertical axis. So if you start down here from infinity, and you go all the way up, the first y value that we see on this graph, the first point that's on this graph has the y value -1. So we're going to start at the -1. It is a closed circle, so that means it includes that -1 as part of the range. So we're going to have a bracket and start with -1, and then if we keep going up, we stop at 1 here, but notice that there is an open circle here. When we're going up, there is no y value at 1. At the value, there is no y value 1 on the graph. So we're going to stop there. It's going to be 1, but we're going to use a parentheses because it does not include that. So that's what interval notation is. Just a note here, sometimes a graph will be continuous, and let's say that this graph just kept going on and on and on and on forever, and it had an arrow at the end. That would be going off to infinity. Anytime that, and you can use infinity in an interval notation, so if this were going off into infinity, your range would show that, well actually domain and range, it would be going off and covering all of your x values to the right and all of your y values up. These would be infinity, and anytime that you're using infinity, you do use a parentheses because you can't include infinity because it keeps going. So that's just something to note there. You can have infinity in the interval notation. All right, when we look at this one, again, x value, actually, let me back up. I forgot to talk about whether this is a function. So notice that if I put a vertical line through there, it goes through more than once. It goes through right there and right there. So that is not a function. All right, and then this one, if I'm going from left to right, notice that here I have an open circle at the x value -2. So I'm going to use a parentheses, and I'm starting at -2 and moving to the right, and I'm stopping at 2. And there is a closed circle there, so it's including that 2. So I'm going to use a bracket there. So open here because that x value, when I start from left to right, increasing. So this is open, not including that x value -2. And then it does include this x value. So I'm going to use that bracket to show that it's including that number. So that is the domain. The range, we are going from looking at the vertical axis and starting with the lower number. So we're going to start down here and go up. The lowest y value that we see on this graph is -2. And there is a solid circle at -2 here, so this is going to be inclusive. Even though this one's open, there is a y value of -2 on that graph. So, and then we go up all the way to 2. And again, there's not a solid or open circle there, so we assume that it is inclusive of that since there's not an open circle there denoting otherwise. So this will be a closed bracket. This one is a function because no matter where you draw that vertical line, it will only go through once. So this is a function. Okay, so that was a very quick lesson on domain and range and what the meaning of functions are and how you can tell whether a function is indeed a function based on a graph using that vertical line test. So that's it. All right.